So now that we defined what a high signal or what a binary signal is, meaning 1 or 0, we can talk about what that means physically when we're trying to communicate that signal across computers or data acquisition devices. So typically 1 is always represented by a high voltage signal. So most computers, 1 is represented by 3.3 volts or 5 volts, while for most industrial applications, positive 24 volts is used. All right. For low signals, zeros are typically represented by signals that correspond to 0 volts or the ground reference, right? So common mode is referred to as true transistor logic. Um, the common method used for transmitting digital numbers is referred to as true transistor logic, where any voltage between 2 volts and 5.5 volts is considered to be true, and then any voltage corresponding between minus 0.6 and 0.8 is considered to be equal to 0 volts or 0, binary. All right. So two ways to typically store to transmit digital information is either using registries, which allow for parallel communication, where we can store. This is an example of a 4-bit register. We can store values uh, uh, at the same time, and you can change the 4 values using these 4 individual connections. So each bit requires a wired connection. So the nice thing about that is you can transmit all the bits information instantaneously, so it's very fast. More commonly, I would say now that computer rates have increased, is the use of serial signals, which allow us to communicate basically using a series of high and low pulses. We can communicate digital numbers as long as we know the rate at which those data is being transmitted. So if we know the rate of our signal, we can communicate a digital word over a quick amount of time using those high and low pulses.